Welcome to Call a Doctor. Last week I talked about, last month I talked about using GitHub Codespaces with the HSDS repository. And this week I'm going to talk about using GitHub Codespaces with the h5pyd repository. In contrast to the HSDS Codespace, this Codespace is really more about how you use HSDS, not about the internal features of HSDS. So there's a few variants in how the Codespace is set up to make it more useful. So let me share my screen. All right. So here first, let me go and illustrate how this works. So GitHub Codespaces are a feature that allows you to run your repository in the cloud. And to use it, you go to github.com and go down here. There's a Codespaces page. And you'll see I already have a Codespace running. So the Codespace is almost like a cloud-based virtual machine, right? So this one's called Verbose Broccoli. And if I wanted to make a new Codespace, you say new Codespace, you select repository. So I would choose HDF Group h5pyd in this case. You can select which branch you want and which region. So I would use US West in this case because I know I'll be using cloud resources that are based on the West Coast. And then you say create Codespace, and in a few minutes, the Codespace will start up. So rather than make you guys wait for that, I have one already running over here. So once your Codespace starts up, so I'm running in Chrome, you can also run in VS Code. You have a terminal and you have your typical edit page here. And if in the terminal, if I type hsinfo, I'll see that I have HSDS running on localhost. The username is testuser1, the password is hidden. I have a home folder and 4 nodes. So what's nice about this is that you have your own unique instance and it didn't require any configuration whatsoever, right? Once you create the Codespace, this will all be created automatically, more or less. You can run any of the h5pyd tests just here in the terminal. So if I do cd test hl, and here are the integration tests. If I say Python test attribute, that just runs, right? So all the integration tests and unit tests will run just like they would if you had installed this on your local desktop. So you'll see in the repository, there's a folder called examples, and I thought I'd run through these different examples. So first one's called read example, and I have it here. And it's quite simple. It just, starting here, prints the version and opens this domain. So domain path, we go up, it's /home/test user1/test/tall.h5. So this is a HDF file that's been uploaded into HSDS. Except it actually hasn't. This happens the first time you run this example. So when you do the h5py.file, this domain path, there'll be this IO error and says it's not found. And then it'll call load file, which is up here. And load file will do some magic to grab this HDF file from the cloud and run hsload on it and then return. So just another thing to, trying to minimize the amount of frictions users will need in running these examples. And so I can illustrate this. If I do hsls/home test user one test, there is nothing there. But if I go to examples and say Python read example, py. Okay, I'll just walk through the output here. So it says running command hsload s3 colon blah 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 to home/test user1/test. hsload complete, and then it just iterates through the contents of this domain. So there's a group G1, a group G2. There's various data sets. It prints out the data set values, and so on. And then it runs this h5py visit, and you visit all the different groups and data sets. All right, so that was the read example. And now there's also a write example. And the write example is a kind of interesting way to see what the throughput is with HSDS. So in this example, there are various arguments you can use to define number of columns, number of rows. And what it does, it makes a data set or the given number of columns and rows and writes to it and then reads back. And then it lists what the throughput is. And there's also an option to use compression. Okay, and the other interesting thing is that it works either using h5py and the h5 library or h5pyd and HSDS. So if I go here and I say Python write example.py, you'll say usage is Python write example.py, and number of rows, number of columns, log level, file path, compression. So if I do Python write example and say big file.h5, it will create a normal HDF file in this folder. And writing that file, so the size was 2200 by 12,000. And writing the file, the writing rate was 46 megabytes per second, and reading rate was 313 megabytes per second. And I think it's by default is using gzip. So if I do list.lh big file.h5, you'll see it's 50 some megabytes. All right. So now if I run this instead with this option, HDF5 colon / home, that's user1 big file at h5. So the HDF5 colon / is to distinguish this from a POSIX path, right? So if you have HDF5, the application knows that you want to talk to HSDS, not talk to a local file. So if I run this, oops, I get a hyphen instead of an underscore. Same, if I run this. So our writing rate was 65 megabits and our reading rate was 154 megabits. And so this compares, yeah, it's a little faster writing compared to h5py, and the reading was a little slower, right? But in the same ballpark, more or less. Right. And again, the interesting thing is that you can vary the compression or the size or the type and then see how these results change. Right. And then the last example I have currently here is this one where we read data from S3. So the previous examples, the read example and write example in this case, were reading and writing POSIX, right? So there's kind of like a virtual disk as part of the environment. It goes away when your Codespace is deleted, but in the interim, it acts like a normal POSIX drive. In this case, we're actually going to be reading data from S3. And so the latency will be greater because you're not just talking within your own pseudo virtual machine, you're actually going across the internet to access data from AWS. So if I go here, and this also, it's a Jupyter notebook rather than just a command line thing. So if I run this, let me see clear lots. And also I should note that you can choose a kernel here. There's a default kernel that's recommended. So when you first run it, you'll be prompted to select this one and only kernel you have. And so if I run this here, we just import various modules, h5pyd and h5py. Here, I'm running HSLS and this path /nrel/nsrdb. And because I don't want this path in my default HSDS bucket, which is, again, the POSIX content on this virtual machine, I want to get the bucket that is in this S3 bucket. So the S3:/ says, don't use POSIX, which is default, given how I set up this HSDS, but use S3 and get data from this bucket, nrel-pds-hsds. So I run that. And there is a bunch of folders and one file sitting here. And if I go down one level more, /nrel/nsrdb/conus, and also you notice I have a -h and -v. The -h says list file sizes in human readable format, and the -v says provide extra information, for example, the file size. Okay, so here's my parent folder, /nrel/nsrdb/conus, and then I have these 5 domains, each of which is 12 terabytes in size. So next, we're going to open this file in h5pyd. So there's actually an option here to use h5py and to instead access it with the S3FS driver. But that'll be much slower than using HSDS in this case. And we say h5py.file and then this path. And again, the bucket with the S3:/ prefix. So we do that. We open this in 600 milliseconds. And we can do things like lists an attribute in this file. So this ran in just 174 microseconds because by default, when you open a domain in h5pyd, it will gather all the attributes and all the links in that first request so that you don't have to go back to the server for each little attribute or link you might want to get. And then we can list the contents. So these are all the data sets. They could be data sets or groups, but in this case, they're all data sets. And then if we can grab a particular data set, like air temperature, we see it is 105,000 columns by 2,842,000 some rows. And each data set has an ID. There's the shape again. This is the chunk size. So each chunk is 2000 by 500, which works out to be about 2 megabytes. Why should I do it right here? Yeah, 2 megabyte. And the number of chunks in this data set is almost 300,000. So I think one nice thing about working with this data in S3 is that if I wanted to download 15 terabytes or create 15 terabytes of select data on my laptop, that'd be quite a challenge, right? Particularly say I don't have a 15 terabyte drive. But here you can experiment with working with these very large data sets that would be impractical on your laptop. Anyway, so here we're going to access a particular column of the data set. So a data set, bracket, and colon just says select all the rows from that column. And then 1, 2, 3, 4, 5, 6, 7 is just the random column. So I do this, it returned in 2 seconds. And then if I run this a second time, you'll notice it should be much faster, 43 milliseconds, because all the chunks that were accessed in that selection are cached in HSDS. So the next time you go to it, you don't need to go all the way back to S3. It'll likely be in the HSDS cache. And even if you change this column slightly, it's still pretty fast because that column change didn't change the chunks that were needed for the selection. So we can get the min, max, mean of this value. So it's -121 to 431 to 173. I think this is in units of 10th of a degree Celsius. And then we can plot it. So this makes sense, right? Because the X scale is running from January 1st to December 31st. And we see temperatures vary, with night and day cycles, and then gradually get higher towards summer and then lower again. So that's all you really know for basic usage. We can dive a little bit into how the data is actually organized. So there's a h5pyd property called layout. And if I do that, I'll see that this layout class is called h5d chunked ref indirect. And the file URI is s3/nrel-pds-nsrdb and something .h5. So the way this data was actually set up is that they didn't transcribe all the original HDF5 data to the HSDS format. It's used what's called linking. It's basically hsload --link. And what that does is it transcribes the metadata of the file, but the chunks stay in the original HDF5 file. And instead of copying that chunk data, you just provide some metadata that tells HSDS where to grab a particular chunk as needed. So in this case, we have this file URI saying get it from S3 in this location. We have the dimensions of the chunk, and we have this thing called a chunk table. And that's where the indirect part of the class comes in. Because there are so many chunks, 300,000, then describing the location of each of those chunks in JSON would be take a lot of space and be pretty slow to access. So instead, we have an additional anonymous data set. And this anonymous data set we call a chunk table, that's a data set whose entries are locations to chunks in the HDF file, right? So each element of this chunk table data set is a offset and a size to a given chunk in the HDF file we're linking to. And the other interesting thing to note is that, remember back here, when we were listing the contents of the file, it was 12 terabytes. And on Amazon S3, there's a maximum file size limit of 5 terabytes. So what's going on here? Well, this 12 terabytes isn't the size of a singular file or S3 object. The 12 terabytes comes from the size of all the metadata, which is actually in the HSDS format, plus the size of all the chunks to the HFI files that are linked to from this domain. And go back down here. So they've run this HSLoad in such a way that one HSDS domain is linked to multiple HFI files. And so that lets them get around the limit. And if we go here, if we iterate for each of these data sets, get the layout, and then look at the file URI, and then add it to the set, we can see how many distinct HDF5 file URIs there are in this domain. And yeah, so it looks like we have 1, 2, 3, 4, 5, 6, 7. So they've actually amalgamated 7 HFI files to create a larger sort of virtual file. And it's a convenience for users because they don't need to be going back and forth between different file handles. Anyway, that's all I have to talk about Codespaces for today. Again, I welcome you to try out yourself. All it takes is go to your Codespaces and say create new Codespace, and you can run through the exact same example. And I think what I'll do in future Call of Doctors is go through some of the newer features and use Codespace as kind of the platform to illustrate those features. All right, cool. So that's it for my prepared content. Any questions about this or anything else about HDF5? Okay, hearing no questions, we'll say goodbye till next time.
Great. Thank you, John.
All right, okay, bye-bye.